I think they can, but not by pretending a 20-year-old computer is a secret supercomputer. Its real role might be as a low-cost edge device, a teaching tool, or a way to run smaller, carefully designed models locally. The interesting question is whether AI's future has to mean ever larger hardware, or whether
I can see the edge case appeal, but let's be realistic about what 20-year-old silicon can actually compute. We're talking Pentium-era hardware. You can't just shrink a llama model down to fit. Transformer attention scales quadratically with sequence length, and old CPUs lack AVX and modern instruction sets that make even tiny inference tolerable. So it's less older machines as useful tools, and more older machines as a niche class of low-throughput local inference. The romantic version, that efficient software will make vintage hardware relevant.
I think that's a fair correction to the romantic version. A Pentium isn't going to run a modern chatbot at conversational speed, even with aggressive quantization. But useful doesn't have to mean full transformer inference. Those machines could handle classical models, keyword and anomaly detection, tiny distilled models with short context, or act as privacy-preserving front-ends that send only selected tasks elsewhere. And they're valuable for teaching the whole AI pipeline, data, evaluation, failure modes, without hiding everything behind a cloud API. So maybe their role isn't mainstream AI hardware. It's making AI smaller, more inspect.
That's a useful distinction to make. The difference between a transformer and a decision tree. Yes, an old machine can run SVMs, keyword matchers, or a small NLP. It can't run GPT-4. But when people ask, can old computers run AI? They're usually thinking of a chatbot. And the answer there is a hard no. The pedagogical value is interesting though, with one caveat. Teaching students to build and debug a tiny model on the Pentium exposes things that a modern cloud stack hides. Data provenance, overfitting, the cost of a single inference. So I'd reframe it. Old hardware isn't useful for modern AI, but it is valuable.
I like diagnostic laboratory, though I'd broaden modern AI a little. Modern systems still use classifiers, filters, retrieval, and anomaly detectors around the big model, and some of those components can run on very old hardware. The Pentium won't be the intelligence at the center, but it could be the gatekeeper, deciding what deserves cloud processing, flagging unusual sensor data, or enforcing local privacy rules. That makes the old machine less a failed chatbot and more a deliberately.
That's an interesting architecture, the tiered approach. But there's an operational cost. Every time you split a system across generations, you add complexity, latency, and a new failure mode at the boundary. You're building a custom gateway, maintaining 2 inference pipelines, and handling asynchronous task handoffs. For most users, that's a lot of engineering overhead for marginal gain. So the real question is, do we want to build these heterogeneous systems, or should we invest in making the models efficient enough to run natively on modern edge hardware? That's the question that determines whether the old machines end up as meaningful.
For most users, I agree. Buying a modern edge device is simpler and probably more efficient. But heterogeneous systems make sense when the old machine is already there, the task is stable, and connectivity is expensive or unacceptable. The trick is not to give the Pentium a second AI stack. Give it a narrow, castable job, thresholding a sensor, stripping sensitive fields, or deciding whether to forward data at all. That minimizes the boundary complexity. So I wouldn't call every old computer a meaningful AI component. But in constrained environments, its very limitations can make the system.
That's a fair defense of the niche case. The already there argument is real in industrial and government systems where hardware is fixed for a decade or more, like medical devices or sensor arrays. But for the broader AI ecosystem, the real answer is different. The field is already moving toward models designed for modern edge hardware. Tiny ML, aggressive quantization, distillation, running on ARM microcontrollers and mobile chips. That's a real path forward, and it makes the Pentium retrofit question less central. There's also the sustainability angle to consider. Reusing old hardware reduces e-waste and carbon footprint, which is a legitimate policy concern. But at some point, the energy cost of running an inefficient old machine can offset those gains. So I'd say, yes, there's a limited case for the Pentium as a specialized gatekeeper in specific domains. But the real investment should be in making models small enough to run natively on modern low-power hardware. The question that matters is whether we're building a future where AI runs on everything, or one where we build around what we can't replace.